now what we're going to see is the first tutorial example that is prepared for OpenBDLM. So the first step, what is to do is to start OpenBDLM by typing OpenBDLM_main and semicolon because we want to suppress the output from OpenBDLM. Then type return. So we're going to see the only file we have loaded so far is the demo we did in the previous tutorial. So now what we're going to do is we want to use the interactive tool in order to preload data that is already built in OpenBDLM. So we're going to type 0. So, okay, we have to enter a project name. Here we choose to call it example _disp. Okay, then type return. Do we want to create synthetic data? No, this is not the goal here. Okay, so here what we want is to load raw data from scratch. So what we're going to do is you choose the option 0 to build a new database. Okay, now this data loader opens up, and what we're going to do is to select the data, and here data should be placed in the folder data here. We're going to double click here. Here we directly want to load data from a raw CSV file. So we're going to click on CSV, and we already provide data in example.disp. So you can see here if you go in data, CSV, example disp, I already have a CSV file, which is basically simply a comma separated variable text file where I have in my first line the header. So this is the name of my data, and then I have simply here my reference timestamp into quote. Then what I have here, the first input is my timestamp, the second one is the data value that I have, and I have a text file that contains here what my sensor has read. Okay, so what we're going to do here is to select that time series and add it here. And done. Now, for this example, we only want one time series. Okay, this is going to be automatically preloaded. Now, OpenBDLM will tell you, okay, what does your time series look like? So here, the first thing we can see is that we have data from 2013 until 2015. And the green line represents you for your displacement sensor here because it's displacement. What is your data availability period? Then you can see that here, these are the timestamp for the entirety of your time series. So what we can see here is that the reference timestamp is 1 hour. This corresponds to this each point here, which represent the most frequent timestamp in your time series. But you can see that for different timestamp, we can have different timestamp that are here represented in log space. We're going to close it for now. This is the raw time series. So what we can see is that we have the superposition of a daily cycle variation and a seasonal cycle variation for a little bit over 2 years. So we can close it from now. So the raw data that we have here is recorded for a timestamp of 1 hour. So what we want to do here is to resample this to reduce the number of data points we have to process. So to do this, in the menu, we're going to choose the option 4 to resample. So now the timestamp we want to use is, for instance, 6 hours. So 0.25 days. So I'm going to type 0.25 and type return. So now what we're going to have is OpenBDLM is going to reprocess the data and show me when I have missing data. So you see, because now the synchronization of my timestamp has changed, I have those points in red here indicating where I have missing data. I can close this one. These are my reference timestamps. Now you see is 6 hours, contrarily to the 1 hour timestamp I had initially. So this is my raw data that I have. Now I don't want to make any more changes. I'm going to say option 7, save and continue. Okay, now OpenBDLM will return me one last time the exact same set of figure. Now, what I have to decide is how many model classes do I want for this time series. In this case, it's going to be a single model class. This is the default option for most cases. Then we have to decide which component we want to use to model this time series. So in this case, we have 11. So here you can see what are the reference number for the different components that are preloaded into OpenBDLM. So the first component is going to be 11. Then we're going to have 2 times 31, 31, 31, and finally a 41. What does it represent? 11 is the local level. This is the average baseline. So this is the response of the structure without the reversible external effects. Then the 231 represent 2 periodic components. The first one is going to have a period of 1 year. The second one is going to have a period of 1 day to represent the seasonal effect in the response. The other one, the daily effect in the response. And finally, the last component, 41, represent the autoregressive process. This is kind of my residual term to capture the variability that is not in my other component, but it has neither the observation noise. So this is a common setup for many time series. I type return. Now OpenBDLM automatically load the file, created for me all the necessary model configuration, and created a config file that would allow me to rerun the same analysis in the config file /cfg example _ dip. This corresponds to the name I gave to the file. So if you go in config file, you're going to go here cfg example _ dip. You can see so now I'm going to type Q to quit. And I have here the configuration file that appeared. This is the same project I gave. This is the data that was loaded and pre-processed for OpenBDLM. Now it shows how to reload that math file. I have my model configuration I specify in OpenBDLM. And here I have all the parameters that are associated with these components. I have my initial hidden states and all the options that were currently selected in my OpenBDLM. So now what I can do is I can go back in OpenBDLM and I see that my example this is already preloaded. So I can choose option 2 to have access to this file. And now the first step that I'm going to do is to here train the model. But before training the model, by default, OpenBDLM say my training period is my entire data set. So here what we can show is to restrict the data that's going to be used for training the model. To do this, we can type option 13. So here option 13. So by default, the training period is from the first till the last day. We're going to modify by choosing option 1. The first day is going to be the start of my training period, and I want to restrict the training period to only 180 days. I'm going to type 180. Perfect. So now I restricted my training period. Now it's time to train the model. So to train the model, I'm going to type option 1 for learn parameter value. Option 1, and I want to learn using here the Newton-Raphson algorithm. Option 1 again. So now the Newton-Raphson algorithm has started. So it uses a training period of 180 days. Maximum number of iteration 100, maximum time to train 60 minutes, and this is my convergence criteria. And what you can see here is that this here is getting some action. This is MATLAB that, if it's available on your computer, gonna start the parallel pool in order to use multiple core on your computer to speed up the calibration. Okay, and this might take a little time to initialize. So this is your initial log likelihood, and the objective is to tune the parameter value in order to maximize this likelihood. So you see that here is going to modify each of the parameter. In practice, this process is fairly long. It is much longer in OpenBDLM to learn the parameter value in comparison with estimating the hidden states. So the full estimation of parameter here might take several minutes. Okay, now the optimization of parameter converge. So what I can do is I can go and ask OpenBDLM to estimate the hidden states. So I can access this through option 3, estimate hidden state value. Before doing this, another thing that will greatly improve my result is to learn the expected value and variance for my initial hidden state. I can do this through access option 2. So if I type option 2, I'm going to estimate using the Kalman smoother my initial hidden states. This is done. Now I can access option 3 to estimate my hidden states. Then I'm gonna choose here, for instance, filter. OpenBDLM is computing my hidden states, calculate the log likelihood, and here is gonna plot all the figures for me. So this is my autoregressive term. Again, the autoregressive term is like a trash. It's what cannot be explained by my model. So be careful when you interpret this to look at the amplitude. That term might seem to be big, but it's because the scale of the term is already adjusted so that you can see it with maximal amplitude. So this is my daily periodic component. So the second hidden variable, you don't care about it. You always care about the first one here. And what you can see here, it seems to be a black line, but actually it's because here the cycle is so small that you cannot see it. In this case, I'm gonna close OpenBDLM, so I'm gonna type Q. So here I have the same daily periodic component. If I zoom in, you're gonna see here, and these spikes, why do they look like spikes rather than looking like a sine? This is because our time step is 6 hours. If our time step would have been, for instance, 1 hour, we would have seen a really nice sine-like line. Okay, this is the second component for our yearly periodic component. We can close this one. We're interested in this one. This represents the amplitude of the seasonal effect. So we can see here, and the black line represents the expected value. The green line represents the plus or minus 1 standard deviation confidence interval. Now we have here our local level, which represent what is the baseline response of our system without the reversible effect applied on it. So we have here the expected value in black, again, plus and minus 1 standard deviation in green. And finally, this is the displacement data that is predicted by OpenBDLM, from which the observation noise has been removed. And we can see that we overlaid the OpenBDLM response with the real data. Both are almost coincident. Okay, so if you want to have access to the file again, I remind you, type OpenBDLM, and this file is still loaded too. You can repeat any of the steps we've seen here. Go back in OpenBDLM, one thing you can do is that you can export the current parameter value, because the default one that was created when you create the file all use the default parameter value. If you can go here and you're going to say option 17, and you're going to export in configuration file, option 1. So the file already exists. Do we want to overwrite? Yes. So our file here is going to be modified to include the newly optimized parameter value that you can see here, those that were estimated from the Newton-Raphson algorithm in OpenBDLM.